Attendance online, good day. And today I want to speak a bit about how we used AI for detecting buildings. To be more exact, how we used it to detect urban landmarks. Urban landmarks has always been an important aspect of our life. We use it to transmit where we are, to see where we're going, to even enhance our cultural experience. So, why would we need to detect these urban landmarks, and why do we need to do them very fast and very quick? Because nowadays, everything happens with a mobile device. So, detecting urban landmarks is an important feature that enhances other ones, like urban planning and development, improving navigation and wayfinding of tourists, of vehicles, of autonomous stuff. One of the most interesting one is the one that I will further go into the presentation, is how we can enhance the cultural and historic preservation and cultural experience of the people. We can use it in disaster management. Like you can find online several studies and several technologies which can predict the state of an urban landmark. How well is it preserved? How degraded it is or not? Of course, security and surveillance is another new aspect. And to make a link to the presentation beyond, the image is not mine, as you can see. I created it with ChatGPT. It's cool. And I have said that just to create a link with the formal presentation. Okay, so moving a bit further, we need to make a clear distinction, because even if both of these type of images show urban landmarks, they are used in two different aspects. So one are the satellite images or aerial images you can see, where usually they are taken by a plane, a drone, and they are used for mapping and terrain recognition. And then you have the city buildings, that you can find them in literature, or urban landmarks, which are taken usually by digital cameras or other aspects from the street view. We will focus more on the second part. So, when we go to the street level, for us now, when we take out our phone, and the group in the past showed us Spotlight Heritage, for example, where they invited you all to take out your phones and find out information about certain landmarks of Timișoara. These kind of activities are not only specific to Timișoara, it happens in all big urban centers. Now it seems seamless. Now it seems that it's easy, but in fact, technologically speaking, it's not that easy. Because you get a lot of distractors, as we call them, or things that change in the perspective. Even if you know what building you are looking for, we as people, we can adapt. We can ignore the people in front, we can ignore the, the new bushes, or all the things that change. And system cannot. So any kind of change in weather conditions, sunlight, people, new places to drink a beer, will change the way it will detect or not that landmark. So then, the community, the academic community and the industry are continuously trying to solve this problem. And now if we look a bit, everything started around 25 years ago, when first it started with the idea of looking into the image itself to find patterns, as you can see in the left side. Of course, this had certain clear limitations for people that are used to looking at images. If you change the perspective too much, it wouldn't work. Of course, in the beginning, it gave results. If you were in a good position, in a good perspective to the landmark, you could find it. Then we moved a step further, and we tried to find certain aspects of the building that are unique, as you can see in the right picture. And that worked for a while. Of course, here the problem is that everybody usually, once several years, will do a lift up of the building. We'll change the colors, we'll add something to it, and then the algorithm will not work anymore. But fortunately, the things move forward, and then we got more better at detecting pixels or clustering together pixels that have meaning, as you can see in the images here. The algorithms got faster, the processing power got faster, and then we could match better things. This image, what we call shift, so invariant features of the image, could compensate to a point the changing in the system, the changing in the weather, and all of the problems that you can see. But of course, we still had a problem. The problem was, for example, as you see in the right image, far corner, what happens when you have a lot of people in front? What happens when you have two similar buildings, like you have in most of Europe, in two different countries, in two different cities? It looks the same because it's the same style, built by the same architect. It will fail. Of course, it will not fail in big landmarks, key landmarks like the Eiffel Tower or Oxford Building, but it will fail in smaller. But then we moved a bit further and said, what about if we try to understand the image itself, understand what pixels have to offer? And this was early 2010, when we had proposals on how to divide semantically the pixels between what's a building and what's the foreground, the background, and other things. And these were what we could do without using AI. Now, AI came to our rescue too, from the beginning of 2010. With the power of AI, we didn't learn any more features. As you can see in the upper part of the feature extractor, we needed to do all of this, and it was a lot of grunt work, because you needed to create features, you needed to learn them, you needed to cluster them, and then a lot of mathematics came into play with near neighbor, k-near neighbors, and other clustering algorithms. Now, we could bypass that to a certain point and learn them. And then we got better results. And before going further, I would like a bit to explain the different basic types of AIs or used in this domain. So you will hear semantic segmentation, which means that every pixel has a meaning. Every pixel has a certain class associated to it. Then you would see classification and localization, the fact that a certain part of the image represents something, in this case, a cat. Then we have the next step, which is object detection, where we can differentiate between different classes. And the last one is instance segmentation, where we have object detection and a semantic to it. So we will say that it's not only a cat or a dog, but we can differentiate between dogs. These aspects clearly have pros and cons. When using semantic segmentation, for example, you can understand the environment, but you cannot differentiate between two dogs. They're both dogs. When you try to classify, you get the limitation that in one frame, in one image, you have only one classification. That's the big limitation of it. In the second one, when you make a more adaptive classification, you go to object detection, where clearly you can detect different objects, but it's an exponential problem. If you want to identify 10 different objects, the problem will be 10 times harder than detecting one object. So basically, it becomes a scaling problem. And of course, behind the scenes, being AI, you always have the data problem. The data needs to be exponential too. Of course, we have certain types of methods to optimize it, to make it more use case prone, but still every kind of AI used has certain deficits. But going back to our problem, how to detect buildings, first we added the layer of understanding the environment. As you can see, depending on the use case, different techniques were used or different classes where you tried each pixel in the image to say it's a window, it's a door, it's a pavement, it's a vegetation, all of that. Why did we do that? Or why do we want that? We want this because we want to limit the matching area. As you can see in this example done in Timișoara here, by using the semantic segmentation, we isolated what's a building from the rest. We took out from the algorithm the parts of the people and the terraces of the bars and the sky and everything else. We took it out and then we compared only the rest. This gave better results. Probably the people online will see better identifying what building it is in the last image. This was probably now, looking at it backwards, it was not that big, but at that point, we managed to eliminate a lot of false positives. The second one, we went further and said, okay, let's try to use object detection, and we did. As you can see in this example, we had the same scene, and by using object detection, we could easily detect buildings. One drawback or one negative aspect of the previous method was the fact that if you have two buildings in the same image, it's pretty hard to differentiate which one is which. By using object detection, you can do this. So, of course, this thing got bigger, went global, and Google, in this case, took the problem at hand and created its own data set, which scaled logarithmically and went global. Of course, this will not solve all the problems. This just gives us enough data to train, enough data to get better. But in terms of urban landmark detection, the clear problem is not size that much. The clear problem is the fact that each city is unique. So even if you can use the data that Google offers and you use it to pre-train, to refine, you still need to have a lot of data collected from the location you want to do this. Okay, so this was my presentation. I tried squeezing it in a bit to go back to the schedule. And I have only one question in Menti, just a day-to-day question. Do you think the AI solutions will be better at recognizing buildings than we do? If we think about it, every one of us has the desire to show that we saw that building, we know that building, we know the history of the building, we know all of that. All these things AI are doing now and creating more immersive experiences for everyone. But will they manage to do better than us?